Class number 10. So in this class I will discuss a topology which consists both switching and routing. So the topology for this class is we have two PCs, PC1 and PC2 on one side and PC3 and PC4 on the other side. So in order to connect all these PCs together, so we have switch 1. What switch 1 will do is switch 1 will establish the connectivity between PC1 and PC2, and we have R1 and R2 in between, so they can do the routing between this 10 network and 192.168 network, so that we can able to communicate all these four PCs. So in the end we should be able to ping from PC1 to PC2, PC1 to PC3 and PC1 to PC4. So let's see the first scenario. From PC1 we are pinging 10.0.0.2. So what first PC1 will do when we issue this command? So we are asking PC1 to send a ping request for 10.0.0.2. So as we are requesting to a ping, it's in the same network, PC1 should be able to directly reach that PC. So in order to that, it has to send this ping request. So source IP will be 10.0.0.1 and destination is 10.0.0.2, because this is the PC sending the ping request and the destination is 10.0.0.2 because based on the command we have given here. Then source address will be PC1 MAC and destination address should be PC2 MAC. So how PC1 will know about PC2 MAC address, right? So in order for that, it will send ARP request, right? So let's see what happens with the ARP request. So PC1, to know about the PC2 MAC address, it will send a ARP request. What is the content of ARP request is who has 10.0.0.0.2. Okay, so ARP request will not contain any IP. Okay, it is based on the MAC address only. So from MAC address will be PC1 because who is sending this ARP request is PC1, and where it wants to send, it is looking for 10.0.0.2 but it doesn't know where it is. So that's why it is using this last address in the MAC address, which is all Fs. It is specifically for the broadcast. Broadcast means the packet is intended for all the machines in that network. Okay, so what happens with this ARP request is once it comes into this wire, it will reach the switch. So what switches will do? Switches will do two things, L and F, learning and forwarding. So what is learning? So the process of learning, what switch will do is whenever it receives a packet like this, it will check the source MAC address. Okay, and it will add an entry here. Okay, so based on this packet, it has received this packet from on Ethernet 11 with the source MAC address of PC1. That means that particular machine is behind Ethernet 11. So it will add this entry, PC1 is behind Ethernet 11. So this is learning entry. Now next it needs to look at the destination MAC address and needs to forward it. In this case it is all Fs. So what switch will do when it sees the all Fs in the destination MAC address? It will send it to all the ports except the received port. So this ARP request, it is received on port 11. So it will send it this way and this way. So it will make two copies of it. Okay. For suppose if you have another link, it will also make another copy, 3 copies. But in this topology, it will make 2 copies and send it one from this interface and send it another from this interface. So when the packet goes to the R1, R1 will not respond for this ARP request because it does not have that IP. But when the packet goes to the PC2, PC2 will reply back for that because PC2 has this particular IP address. Okay. So now ARP reply PC2 will send ARP reply. So ARP reply from address will be PC2 MAC, because this is the one replying back for the ARP request. To destination, whoever requested that ARP, right? So in this case PC1 requested that, so it is sending to PC1. In the ARP reply it will tell its own MAC address, my MAC for 10002. Okay, so once the packet comes here, it will reach switch 1 on Ethernet 2. What switch will do whenever it receives a packet? It will do learning and forwarding. How it will learn? It will look at the source MAC address. So source MAC address of this packet is PC2. So it received this packet from Ethernet 12. So it will add this entry. So PC2 is behind Ethernet 12. Next it needs to do the forwarding by looking at the destination MAC address. So the destination MAC address is PC1 MAC. It will go ahead and check it MAC address table. So PC1 is behind Ethernet 11. So it will move this ARP replay packet into this link. So PC1 will receive the ARP reply and it will identify the MAC address of 10002. So now PC1 have the PC2 MAC address. So now actually this packet will be sent by PC1. So this is the actual ping request. So source IP will be 10001, destination is 10002, source MAC is PC1 MAC, destination MAC is PC2 MAC. This is learned by the ARP process. If it learns once, it will keep it in the cache and we use it for like some amount of time. Depends on the system. Once this cache clears, then if it wants to send a packet to PC2, it will do again the ARP request process. Okay. So now this ping request packet will come on this link and will come to the switch. What switch will do? Learning and forwarding. So is there something new to learn? No, because already it has this entry. This particular PC1 MAC address already has an entry. Okay. So it won't update anything here. Then next, forwarding. So where it will forward? The destination MAC address is PC2. So it will check its MAC address table and it should be PC2 is behind Ethernet 12. So it will send it this way. So now the ping request received by PC2. Now PC2 will reply back. So when PC2 replying back for the ping request, it is creating a new packet for the reply. So source will be 10002, destination will be 10001. Source, now this is replying PC2, so it will put its own MAC address and it will put the PC1 MAC address. How does it know the PC1 MAC address? Because whenever PC1 sent ARP request, it will note down that MAC address of the PC1. So that's how it was previously learned about the PC1 MAC address. If it does not know, it will send ARP request. Okay. Now this reply packet will come on the link and it will come to the switch. What switch will do? Learning and forwarding. So learning based on the source MAC address. So is there anything new that it has to update the table? No, because it already knows that PC2 MAC address is behind Ethernet 12. So nothing new to update on the table. Then it needs to do the forwarding. So it will go and check destination MAC of this particular one is PC1. So what the table is referring to? Ethernet 11. So it will take that reply packet and switch it to the Ethernet 11. Okay. So now the ping reply reached PC1. So this happens for one successful ping. One successful ping means ping request reaching the target and target replying back with the ping reply, and it should be received by the whoever sent the ping request. So one successful ping is combination of two packets, ping request and ping reply. So this is the process happens in this topology when pinging from PC1 to PC2. Now let's try to ping 192.168.0.1. So now we are trying to ping from PC1 to PC3. So once we issue this command, what PC1 will do, it will check the destination MAC address and is it in the same network or not. So in this case it is in the different network. So if it is in the different network, it needs to send this packet to gateway. So how it can send the packet to gateway? It just need to put the MAC address of the gateway so that the packet will go to the gateway. So for this ping request, source IP will be 10.0.0.1, destination will be 192.168.0.1, source MAC will be PC1 MAC, gateway MAC should be in this topology the gateway is 10.0.0.254. So it needs to know where this IP is configured on the NIC and its MAC address. So in this case it doesn't know. So if it doesn't know, what it will do, it will send the ARP request. Okay, so let's see what will be the ARP request. So ARP request does not have IP, so sending ARP request. So what is the content of ARP request? Who has 10.0.0.254. Okay, so source MAC address will be PC1 MAC and destination is all F's because PC1 doesn't know where this IP is. Okay, so that's why it is using this broadcast address. So the packet will come into this link, and once it reaches switch 1 Ethernet 11, what it will do, learning and forwarding. Is there anything new to learn with based on the source MAC address? No, because it already knows that PC1 is behind Ethernet 11. Next, forwarding part, it will look at the destination MAC address. In this case the destination MAC address is all F's because it's ARP request. So what it will do, send it to all ports except the received port. So it will send this request this way. It will make 2 copies and send it one towards Ethernet 12, another one on Ethernet 1. So PC2 will receive this ARP request, but it won't respond because it does not have this IP. Once the packet arrives on the R1 will reply back because it has this IP. So now R1 will reply back with its own MAC address. So R1 will send ARP reply. Source will be gateway MAC address. So whatever the interface MAC address, R1 has it here. And the destination will be whoever sent the ARP request. In this is PC1. So in the content, my MAC for 10.0.0.254. So it will include its MAC address here. So this packet will come on this link and it will arrive on switch 1 Ethernet 1. So what switch will do once it receives this ARP replay packet? Learning and forwarding. So learning happens based on the source MAC address. So what is the source MAC address? The gateway MAC address, whatever R1 Ethernet 1. So it will add that entry. Okay, that particular MAC address is behind Ethernet 1. Then forwarding. So destination is PC1 MAC. So PC1 Ethernet 11. So it will switch that packet from here to here. Okay, so now ARP replay will be received by the PC1, and now PC1 will know the gateway MAC address. Now it can send the ping request. So what will be the ping request? If we look at this link, source will be 10.0.0.1, destination will be 192.168.0.1 because this is where we want to send the packet. Source MAC will be PC1 MAC, destination MAC will be gateway MAC because in order to send the packet from PC1 to PC3, PC1 just needs to send it to its gateway, and the gateway responsibility is to forward it towards PC3. Okay, so now this packet will come to the switch 1 on Ethernet 11. So what it will do, learning and forwarding. Is there anything new to learn on this packet? No, it already knows PC1 is behind Ethernet 11. Anything to do with the forwarding? Yes, it needs to forward the packet. Where it needs to forward the packet? To this MAC address. So it knows that gateway MAC is behind Ethernet 1. So it will move that packet to here. So now packet will arrive on R1. So let's see what R1 will do with the ping request. So once R1 receives the packet, it needs to, what routers will do, it needs to route the packet, right? So first it will check the destination IP. So what is the destination IP? 192.168.0.1. So now it needs to know where to forward this packet, either this way, or if it has another link, or this way. Okay. So how does it will know? One thing, it will know about the networks based on the interface configuration. That is one method. So in this scenario, R1 has two interfaces, so that it will know two connected routes. One is about 1.1.0/30 network, another one is 10.0.0.0/24 network, but the destination IP is not falling under this. So we need to add a static route stating that if you want to send any packets to this particular network, you need to send it to your next hop. In this topology, the next hop is 1.1.2. We need to send the packet to here. So in order to send the packet to 1.1.2, what it should do is it needs to put it in the destination MAC address field. So it needs to put 1.1.2 MAC address, not the IP MAC address. So how does R1 will know about the 1.1.2 MAC address? For that, it needs to send ARP request. Okay, so it will send ARP request for 1.1.2, and once the packet comes to the R2, it will reply back with its MAC address, so that R1 will know what MAC address it needs to put in this field. So once R1 sends the packet to R2, so now R2 is also router, right? So it will check the destination IP address 192.168.0.1. So it knows that one of its interface in the same network. That means the destination IP has the same IP as its one of the interface, so that it can just send it out this interface. So it will put the source MAC address of outgoing interface MAC address. So when R1 is also sending the packet to R2, it will also put the source MAC address of outgoing interface, because it needs to send packet from this interface. So the same thing happens when R2 trying to send. So how does it will know the PC3 MAC address? It will just send ARP request, because both are in the same network. Thing to remember is ARP process only works in machines which are in the same network. Okay, so once R2 will send ARP request for 192.168.0.1, the packet will come here, and switch will forward it here, and only PC3 will reply back, and it will come here. Then based on that MAC address, it will construct this ping request, and it will send it out to PC3. So PC3 will receive the packet. How switch will do the forwarding? Same steps will happen what we discussed previously in this side. Okay, learning and forwarding. So now ping reply. So now PC3 will initiate ping reply. So source MAC address will be 192.168.0.1, destination will be 10.0.0.1. Source PC3 MAC, its own MAC address. Destination, because it's trying to send a packet to different network, it needs to put its gateway MAC address. How it will know? It will just send the ARP request. So the gateway, in this case R2, will respond for that ARP request with ARP reply including its MAC address information. So PC3 will put that MAC address, and it will come here, and switch will do the learning and forwarding. It will come here. Now R2 needs to know where to send the packet. So based on the interface configuration, R2 only knows about two connected routes. One is 192, another one is 1.1, but it does not know anything about 10. So we need to add a static route saying if you want to send any packet to 10.0.0/24 network, you need to forward it to next hop, which is 1.1.1. So R2 needs to put its outgoing interface MAC address. So based on this static route, 1.1.1 is on this particular network. So it will put Ethernet 2 MAC address. and next hop it needs to put MAC address of 1.1.1. So how it will know? It will just send the ARP request for 1.1.1 and R1 will reply back with its MAC address. So it will put that MAC address here. So then the packet will enter here and it will reach R1. So once it comes to the R1, what R1 will do? Check the destination IP and identifies that it is matching with one of its own interface connected route. So it needs to send it out this way. So it will put the outgoing interface address as ETH1, R1 ETH1, and destination 10001, it's in the same network. So it should be able to send ARP request and receive ARP reply. So based on that, it will include the PC1 MAC. Once it comes here, switch will do the learning and forwarding and it will send it to PC1. So from PC1 to ping request went all the way to PC3 and reply came back to PC1. So one ping request and response. So this makes one ping successful. Okay. So this is how the switch and routing works in a simple topology like this. So assignment for this class is build similar topology. You can use any IP addressing scheme, doesn't matter. But yeah, make sure you are able to ping between PC1 and PC2 and PC1 and PC3 and should be able to ping PC1 to PC4 as well. Okay. And verify how switch is learning MAC address. So verify every time you are trying to do the ping and see if there is any change in the MAC address table. So the command will be like show MAC address table. And on the routers you can verify the ARP entries by show IP ARP command. Show IP ARP. And routing table show IP route. On the PCs, if you want to see the ARP table, show ARP. Configuration, show IP. Okay, so once you successfully built or completed this lab and verify the connectivity, make sure you understand how exactly the packet source IP, destination IP, source MAC, destination MAC, when you look at any physical link for ping request or ping reply process. Okay. So once you have done this correctly, you understand the basic concept of switching and routing. In the next classes, we will discuss next topics. That's all for this class.